going to do a lesson on special right triangles. We talked about this a little bit in class today, and we learned that the special right triangle, there's two of them. One comes from the equilateral triangle. And I started it with all three sides being 2. And if this is an equilateral triangle, when you draw the height in, you get a right angle, but it's also the median, so each half of the base is 1 unit. By Pythagorean theorem, then, we can figure out the height. Height squared plus 1 squared is equal to 2 squared. So that means the height squared plus 1 is equal to 4, or the height squared, if you subtract 1 from both sides, is equal to 3. So the height, when you square root both sides, it's equal to the square root of 3. So this triangle here is a 30, 60, 90 because it's equilateral, and you want to memorize that. Similarly, there's a second special triangle that comes from the square. And if you make the sides of a square 1, by Pythagorean theorem, you can find the diagonal. D squared is equal to 1 squared plus 1 squared, which is 2. So if you take the square root of both sides, you can find the diagonal is the square root of 2. So then you take this 45, 45, 90, or an isosceles right triangle, and you have those proportions where this is 1. So you're going to memorize those two triangles and then learn how to use them. So we talked about the benefit of this in class. You used to need to have 3 sides, two out of 3 sides to use Pythagorean theorem, but similar triangles are proportional. So these special triangles are always going to be in the same proportion because, for example, if I take this triangle right here, oops, this one here, and I memorize the 30, 60, 90 here, regardless of if it's really big or really small, it stays in the same proportion. So I can use the proportions to find the missing values. So my first example would be use this with a ratio proportion. I can compare the hypotenuse of the left triangle to the hypotenuse of the right triangle. Because they're both 30, 60, 90s, they're going to be proportional. So then to find the short leg, I can say W compares to 1 and solve the proportion. 6 times 1 divided by 2 is equal to W, so we learned that W is 3. So the other property that we talked about in class was to get from the hypotenuse to the short leg, the quickest way is just to divide by 2. Although you can do a ratio proportion, if that's helpful. Now to get from the short leg to the long leg, we're going to set up another proportion, starting back with the original 6, comparing to 2. But now we're looking for Z, so we're going to compare that to root 3. So again, to solve this proportion, we're going to do 6 square roots of 3 divided by 2. 2 goes into 6 3 times. So that tells us Z is equal to 3 square roots of 3. And then if you look at this pattern, to get from the long leg, short leg to the long leg, you're really just multiplying by the square root of 3. 1 times the square root of 3 is the square root of 3. I'm taking W, which is 3, timesing it by the square root of 3, and I get 3 square roots of 3. So I can get there with ratio and proportion, and I can get there by just multiplying by the square root of 3. So we're going to do a second example. Let's look at this problem number 2 here. By shortcuts, I should be able to go from the long leg to the short leg. Because if going from the short leg to the long leg is just multiplied by the square root of 3, to go from the long leg to the short leg, I can divide by the square root of 3. So x is going to be square root of 6 over the square root of 3, which is the same as the square root of 6 over 3, which is equal to 2 in a square root. And then to go from the shortest leg to the hypotenuse, I can double 2 square roots of 2. So to check my work, or maybe to make more sense of that, sometimes shortcuts are not very easy to understand, so you can solve with the ratio proportion. So I can compare y, to check my work, to 2, because that's hypotenuse to hypotenuse, as 6, because that's what I'm given, square root of 6, long leg to long leg, square root of 3. So when I cross multiply and divide by what's left over, I get y is equal to 2 times the square root of 6 over the square root of 3. And that's 2 times the square root of 6 divided by 3, so that's 2 square roots of 2. So it checked out. Once I have y, it's easy to go from the hypotenuse to the short leg because you just divide it in half. So 2 square roots of 2 divided by 2 gives us that value. So let's do one more example. By ratio and proportion, for those of you that makes more sense, you would say 3 square roots of 3 hypotenuse compares to the hypotenuse of the base triangle as whatever you would like to find, like x, compares to the short leg. Then cross multiply, which is 3 root 3 divided by 2, so you just realize that 3 root 3 over 2 is equal to x, which is what the property says. Just take the hypotenuse, divide it in half, and you get x. So once you know that x is 3 root 3 over 2, you should be able to just multiply that by the square root of 3 to get y. So y is equal to 3 square roots of 3 times another square root of 3 over 2. This equals 3, so you get 3 times 3 over 2, which is 9 halves, or 4 1/2. If you're not convinced, you can get y by ratios. So 3 square roots of 3 compares to 2, because that's the base triangle, as y compares to the square root of 3, because that's the base leg. Now I'm going to cross multiply, and I get 3 square root of 3 times another square root of 3 divided by 2 is y. So 3 times 3 over 2 equals 9 halves, which is equal to y. So that's pretty much how to do a 30, 60, 90. We're going to back up and do a 45, 45, 90. So down here, you have the same idea, but now this is the triangle you have memorized, and you use this triangle because when you look at this picture here, sorry about that, right here, you see that, that's the triangle we want to memorize, so I have that twice. Let me clean this up for a minute. Let's make this, pause that, fix it. Okay, so if you have to find x and y in this triangle, by ratio and proportion, you could say 4 compares to the square root of 2, as x compares to 1, cross multiply, and divide by the square root of 2. So x equals 4 times 1 divided by the square root of 2. You don't usually see answers left in this form, so you have to rationalize. Multiply by root 2 over 2. You learned that last year. Might be a little rusty, but we'll just keep practicing it. And when you finish rationalizing it, 4 divided by 2 is 2. So your final answer is 2 square roots of 2, because this 2 goes into there 2 times. And x and y are equal because this is an isosceles triangle, because the base angles are equal. So do another example there. Down here on the bottom, to solve this triangle, same idea. You're going to compare hypotenuse by ratios. You can compare hypotenuse to hypotenuse, as the leg is to the leg. So x is just 2 divided by the square root of 2. You have to rationalize that. Multiply by root 2 over root 2, and that's 2 root 2 over 2, which is just the square root of 2 for x and y. So the shortcut for this triangle is to get from the leg to the hypotenuse, you times by the square root of 2. And to get from the hypotenuse to the leg, you divide by the square root of 2. So, in other words, here, to get from here to here, you just divide by the square root of 2, which is 2 divided by the square root of 2. So, let's kind of summarize the shortcut. In a 30, 60, 90, if you have the short side, just double, and you'll get the hypotenuse. And multiply by the square root of 3, and you'll get the leg. To go backwards, you would do division to go from the long leg to the short leg. So you would take the long leg and divide by the square root of 3 and get the short leg. And if we practice that, to get to here, this is just 5 halves, because I'm dividing by 2. And then I'm going to multiply by the square root of 3. So this is 5 root 3 over 2. For 45, 45, 90, to get from the hypotenuse to one of the legs, you divide by the square root of 2. And to get from the leg to the hypotenuse, you times by the square root of 2. So, if I need to find x, and I know that this is 6, to get from here to here, I'm just going to divide by the square root of 2, and then I have to rationalize it. So 6 root 2 over 2 is equal to 3 square roots of 2. And I can check my work by multiplying by the square root of 2. And I will get 6. All right. I think that's enough to get you started. Come back with questions tomorrow.